This is going to be building security at scale with Alex Stamos.
Hey, everybody. Morning, friends. Thank you very much for coming out for the day 2 Hangover track. I'm sorry, that's what I meant. Appreciate you coming out. My name's Alex Stamos. For last 5 months and change, I've been the CISO at Yahoo. And today I want to talk about some of the things I've learned and how I think we can apply it overall in the security industry. So at first, we're going to talk about the problem of scale. And I'm going to try to set, back I spent, 12 years on your side of the fence doing offensive security research and consulting. And at that time, I felt that I understood the problems of my customers, but until you walk in those people's shoes, you don't really get there. And so I'm going to try to share some of the numbers and some of the ideas so you understand what it's like to operate security at a company that has roughly 1 billion users around the world. After that, we're going to talk a little bit about a problem that I've seen creeping into our industry in the last couple of years, a problem of creeping nihilism that is much more less technical issue, but more of a morale issue that is causing us from solving real problems. And then I'm going to talk about what I've been doing at Yahoo, just in case, like me, you're thrown into a position that you're not really qualified for. Maybe I'll have some tips that you can apply when that day comes. So some of the theses today that we're going to be talking about. Our industry overall has failed in many ways. We have failed to keep users safe. We have failed to make the internet something that is trustworthy on a day-to-day basis for most people. And a lot of this is because we haven't thought of the needs of scale. And scale is more than machines and data and numbers. It's about diversity, and it's about understanding the actual threats that your real users reach. A lot of this is because of a very monolithic focus on a specific industry, and we'll get into that in detail. Post-Snowden, we have kind of a strand of nihilism that is keeping us from dealing with problems that are real, and instead kind of wrestling with phantoms of incredibly advanced attackers that we expect that every single person in the world is targeted by. And this is a little bit upsetting and something that I think we can change pretty easily. And if you're going to build an enterprise security team these days, you're going to have to actually think more about trust than security. And trust is something that's bigger than security. Trust is about companies building products and designing systems in a way that is consistent with what the user believes is in their best interest, and proving to the user that you have their best interest in mind. Security is then having the technical wherewithal to actually back up your promises. And so we'll get into that in detail. So let's talk about the security industry a little bit and what it means to web scale. So what do I mean by scale? So the obvious scale are things like amount of data, number of systems, number of users. But I'd like us as an industry to start to think a little bit more about diversity. When you have a lot of systems, they're never the same thing, right? Any company that has more than 10,000 systems is going to have a diversity problem. They're going to have old stuff, they're going to have one-offs, they're going to have acquisitions, they're going to have technology that has been orphaned but is still super critical for the company. And as an industry, we often just focus on how do we deal with security with just the new cutting-edge fun thing, and less about the actual diversity of systems we see out there. And if you're a company that has more than a couple hundred users, you probably have a diversity problem too, where your users represent a skill set and a threat models that are different than your own personal experience. And just like any other engineer, security people like to build products for ourselves, and we like to build them for our friends. And that's fine to start off with, but once you start to pivot to actually serving normal people, you really need to start to think about what their actual risks are and what their day-to-day experiences are like. And I think that's really where we've fallen down the most. So who is the prototypical customer of security products? Let's say I want to go start a security product company, either software or a pizza box that I want to sell. And I'm going to go pitch some venture capitalists for $1.5 million in seed funding. What are the logos I'm going to put on the slide of people I've talked to see whether or not my product's going to sell well? What kind of companies? What industry? This is Socratic method. You're supposed to answer. It's not rhetorical. Banks, right? I do a lot of venture capital work. Every single deck has these logos on it, as these are the people I have talked to about my potential product, and I think they're interested in purchasing it. And this is great. I mean, it's great that we have an industry, banks, that have lots of security people that know what they want and lots of budget to spend. Those are all real positive things for a security startup. But the result is, in the earliest stages of building product companies, we get so focused on this problem set and these use cases that we're not able to later on pivot to deal with the bigger problems. And that's because these guys, it turns out, are not representative of other companies. Not just not representative of web scale companies like us, but of companies in general. So let's talk about some numbers so you can kind of understand that. So the biggest banks in the United States count their number of retail customers in the tens of millions. The web scale companies like us, Google, Twitter, Facebook, count our users in the single number of billions. Of unique billions. We have something like 850 million unique users per month, which makes it well over a unique billion people per year. That's a little bit different. Obviously, we have to deal with people that speak every language on the planet from every country that has internet access, where a bank can constrain themselves regionally by language, by legal jurisdiction, which changes the security model a lot. The number of concurrent users for big banks are much smaller. And we're talking about the retail site here. You're talking about thousands to tens of thousands of concurrent users. How many people in this room have logged into their bank or their brokerage account this morning before coming here? Okay, I see 3 hands. How much money do you have in there, sir, that you log in at 9 a.m. to check? Either it's very little or a huge amount. So it's how many people have used either Google, Yahoo, Twitter, or Facebook this morning? Yeah. And a lot of you didn't even use it consciously. Your computer is set up with an account or has an app from one of those, and you've been pinging us every 10 seconds, all day and perhaps even all night, right? Wearing down your battery, sorry about that. So even if we had the same number of users as the banks, the actual number of concurrent users we'd have to handle is much greater. And for our numbers, we're looking at tens to millions to possibly hundreds of millions of concurrent users if you're talking about global events like the World Cup or the Olympics and stuff like that. Number of front-end servers, so you can build a retail banking website with a couple of servers. These guys like to buy 4 of everything, right? Because they've got plenty of money and they like to buy very expensive stuff, and so they end up with perhaps 100 systems on their front end, which is why banks are actually often vulnerable to distributed denial of service attack, because the amount of machines that they have doing this is quite small. And that's why they have to rely on third-party services to deal with their DDoS issues. We have front-end servers numbering in the high tens of thousands. When we have to patch for something like Heartbleed or an Apache patch, the number that comes across my desk is in the 6 figures. And so that obviously changes things a little bit versus trying to keep patching 100 machines at a time. The total number of servers for a bank, obviously one of the differences, all we do is web. So 100% of our systems are there to support our web presence. Whereas for a bank, you have tens of thousands of systems that do totally other things, whether or not that's like institutional banking, running your hedge funds, any market making activity you do. And so this is where they start to get closer, that they might have tens to perhaps low hundreds of thousands of machines. Whereas in the web scale companies, we're talking hundreds of thousands of machines, and there's perhaps some companies in our space that are pushing over 1 million individual servers. A customer value is actually a very important metric for determining what kind of security precautions you can put in place. So a bank customer is worth hundreds to thousands of dollars, right? So I have a mortgage with a bank. That mortgage is worth thousands and thousands of dollars to that bank. And so they're very highly invested in making sure I stay a customer and to make it very hard to move away. Whereas the typical customer of a web scale company, the median customer is worth pretty much nothing, like an unmeasurable amount of money. Every once in a while, somebody will log in and click an ad, and we appreciate when you do that. But for the most part, any individual customer is worth in the fractions of a cent. Which clearly, if you're talking about doing security precautions that are marginal cost per user, that really limits what you can do. Tied to that is customers are extremely sticky for banks, right? So that mortgage that's worth thousands of dollars a year is a huge deal for me to change from my bank. Whereas if you come to us for your sports scores and you come to sports.yahoo.com and it's slow at all and you don't feel like you're just gonna go over to ESPN.com like that, right? There's almost no stickiness at all in consumers that use just media consumption. What's a little more sticky is if you have mail accounts and such, but it's still way easier to change your mail account than it is to change your mortgage or your banking relationship, which is why banks can treat you like crap and you still use them all the time, and why people like us have to actually think about customer experience. Another important difference is that user that's worth a lot of money, that's hard for them to move away, also has a very strong meat space identity tied to their virtual account. If you have an online account with a bank that doesn't match up with your actual real life identity, then almost certainly you're committing a crime. where that is a completely supported function of the web scale companies. We offer two-factor authentication. You can have dozens of different pseudo-anonymous Yahoo accounts tied to a single phone number, right? Because we don't mind. As long as you're using our services, you can be Surfer Boy 1972 and never tell anybody what your real identity is, and that's totally fine with us. But the downside is that makes it very difficult for us to have those backups in place if things go wrong and we lose the ability to strongly identify somebody, whereas a bank always has a physical branch. They have people that can see you personally and look at your ID. They always have backup plans for authentication that can go well beyond what you can do at our scale. And then another really important thing that people haven't thought too much about is that banks from a security perspective are able to take ex post facto action to resolve the problem and to mitigate damage to their customers, right? If you want to see how this works, you can go travel to the Ukraine, go log into your retail banking site, create a new bill pay recipient, and then send them $5,000 and see what happens. And the answer is that person's going to get. The answer is not that person is going to get $5,000 from your bank. What's going to happen is they're going to lock your account. You're going to get contacted on every form of communication that they know of, and a human being is going to be able to look at that and to resolve that problem for you. Because when banks do things, it still takes an incredibly long period of time. It's amazing, it's 2014, and unless you're doing Bitcoin, it still takes 3 days to send money to somebody and have it clear using the banking system, right? But that's not accidental, that's not inefficiency. Part of that is the entire security model of the banking system is based upon the idea that they can audit these things, look for anomalies, give them enough time for a human being to look at it, and then roll back a transaction before something bad happens. Something bad that would happen to one of our users is they could get phished, get their email account stolen, and then the bad guys can log into their email and download their inbox, right? That whole transaction happens in 700 milliseconds. There's no time for us to stop that transaction and to have a human being investigate it, nor honestly at the scale we operate would that ever be possible. Nor is there any way for us there's no good way to mitigate the damage from that. If something like that happens, that damage is done, and we have no way to put that genie back in the bottle. And that's a real big difference in the kind of security protections you can put in place in a bank versus somebody like us. So the result is that when we talk about security for web companies and talk about security for financial institutions, insurance companies, folks like that, we're talking about two totally different metaphors in the real world. Banks are like the Secret Service or this Marine Guard next to Marine One, right? The Secret Service knows who their customer is. It's the president or whatever principal they're protecting. They have a reasonably good idea of all of the different threat scenarios to harm that person, and they're able to build multiple levels of protection around him and to utilize threat intel to figure out whether or not that situation changes. Everybody likes to think of themselves as the Secret Service, and that's great. But the reality for folks like us is a little bit different. We're more like the beleaguered survivors of the zombie apocalypse. We're in a mall, and the mall's all locked up, and right now we think it's only humans in the mall, and we're looking out the window, and there's 850 million people per month running at our mall, and we need to decide which of those people are zombies and which ones are humans that we want to let into our little society. And one, it's very hard to tell just by glancing whether somebody is a zombie or not. And then the other problem is once you let somebody in, it turns out they could have been secretly sick and they become a zombie later, right? And then there's no good way to make them not a zombie. And so the model is very different. We have millions of people creating accounts on our site every day and figuring out which one of those people are doing that because they're a legitimate user, which ones are trying to create accounts because they want to commit fraud elsewhere, and which people are creating accounts to commit fraud on our site is a very, very difficult problem to solve. And it changes the security model completely from a situation where you know who you're protecting and you know what the threats are. Okay, so since Black Hat is apparently turning into RSA in the desert, I thought it would be appropriate to talk directly to the people here who work for a product company. Thank you. Who here works for a company that sells security product? It's okay, you can admit. Okay, good. So there's enough people here to make this useful. So I'm going to talk a little bit about the things people try to sell us. I'm just going to lay this out in the beginning. I hate sales calls. I hate salespeople. It is the worst part of my job is sitting for 30 minutes with somebody in a sport coat and them explaining to me what my problems are for 29 of those minutes. And then in the last minute, they tell me what their product does. So if you're a salesperson, I'm happy to chat with you offline. about how not to be that person. But the other thing is, I've got some advice here about the kinds of products you guys are building and why they don't operate at our scale. And this is not relevant just for us and for the Googles and the Twitters of the world. I think this is becoming relevant for more and more companies, and we'll talk about at the end why. So some of the things people try to sell us. People try to sell us super smart pizza boxes, and by pizza boxes for the non-technical people in the room, I mean 1U servers, right? Super cheap Taiwanese-made Intel servers with the Linux kernel on it and some custom software that then they want us to take that and put it into our critical path, something that's gotten hours and hours of regression testing done on it that then we're going to put in our critical path. They also want to sell us boxes where there's a 1-to-1 ratio between those devices and our front-end servers, right? So when a salesperson comes in and says, just buy one for every web server, and my answer is, great, I'll take 62,000 of them, that's a great day for the sales guy, but it is unlikely that I'm able to get the GDP of Uruguay for a single security product out of my CEO, even though she is very supportive of security. So people try to sell us these very smart pizza boxes, machines that do all of the intelligence on board, right? And this is what the security industry keeps on doing, is that we're going to take these boxes, and Moore's law makes what you can do in 1U more and more incredible. Like it's pretty amazing now what you can do in 1U of computation and within 300 watts of power envelope. And so instead of making it cheaper or making it more power efficient, what they do is they shove more and more features in there and more intelligence. What we would much rather buy is distributed dumb sensors, preferably made out of software, that have the ability to make intelligent decisions centrally. And so the metaphor that's good here is police on the corner versus CCTV, right? So these pizza boxes are fantastic if you can afford them. That's the equivalent of having a policeman on every corner in your city, because they have the intelligence themselves to look at something, to decide whether something bad's happening, and then to interrupt it and to make sure that that bad thing stops. That is really not scalable for most cities, and that's why you see a lot of cities doing the CCTV stuff, where you have dumb sensors that can see just as well as the police officer but have no intelligence, but then bring back all that information to a central place where a much smaller number of intelligent beings, generally human beings, but also things like facial recognition, are able to then determine whether or not there's an anomaly, and then they dispatch somebody else to go take care of the anomaly. And that's, while I don't like the Orwellian metaphor of the CCTV, realistically, when you operate the scale we operate at, we can't afford a cop on every corner. What we need is to look at these dumb sensors and figure it out. So I'm going to give you a good example of how this works. So this is a switch from a company called Arista Networks. This is the most expensive switch you can purchase from them. Arista is famous for making dumb switches. And dumb is not an insult in this case. That is intentionally the model here, is that companies at our scale and people doing cloud computing we're getting sick and tired of paying multiple thousands of dollars per 10 gig port for devices that have way more intelligence than we need, right? Switches, I'm not going to name any companies that make things that are in green, but switches that can do all kinds of crazy things from layer 3, layer 4, layer 5 up to layer 7 in a switch in software that you don't actually need. What companies like us need is we need a switch that takes an Ethernet frame and then puts it out another port. I mean, I know that sounds crazy, right? But that's like fundamentally kind of what we need in a switch. And so Arista makes these switches, and they're very popular with web scale companies and cloud computing hosts. This particular one has a little over 1,100 10 gigabit copper ports with 30 terabits per second of backplane, right? This is the most expensive firewall you can purchase from Palo Alto Networks. Now, I love Palo Alto. It's a great company. They make great products, and that's why I'm using them as an example, because if they fall down here, everybody's going to. This is a very smart device that will look at all your internet traffic going back and forth, figure out what's going on, and then make intelligent decisions whether to let it go on or not, right? And this isn't a Palo Alto pitch, so I'm not going to go into details, but this is providing lots of different security services that are very useful for folks like us. This is the most expensive one you can buy, and it is able to do 120 gigabits of throughput if you turn on the security features, right? Not all of them, but most of the security features you can do at that speed. So let's say I'm a different VP at Yahoo, and it's my job to build out a new building in our data center. And we're like, great, we're going to have 1,000 cheap Intel machines, each one of them with 6 consumer hard drives attached, right? So now we get 18 terabytes per 1U. And each one of those is going to be a Hadoop node. And we expect there to be a huge amount of internode traffic because we're doing Hadoop and other kinds of computational stuff. So we're going to want a very high switch with a lot of backplane speed so that the internode traffic is very hard. So I go out and I buy an Arista switch. How many Palo Alto boxes, the most expensive Palo Alto firewall, would I have to buy to provide those security services non-blocking between my servers plugged into the switch? Anybody want to do the math real fast? 20? That's really bad math. Anybody else? Sorry? 250, yes. I would have to buy 250 firewalls to provide security services for one switch. So as a result, I have my switch, I have my 1,000 servers, and then we go get the lay down concrete and build a whole nother building. And that building we stack up to the roof just with Palo Alto firewalls. That is obviously not scalable, right? The other problem is that power is death for companies like us. The absolute #1 cost of the amortized cost of a data center over 10 years, if you take the land, the people, the building, all the batteries and all that stuff, all of the computers, if you take all of that cost over 10 years, still the #1 cost is electricity. And this switch is gonna pull 5 kilowatts, right? So the average American home pulls 2 kilowatts. So you're talking about 2 houses, 2.5 houses here. These firewalls are pulling as much as a small subdivision of a city, right? Which is obviously never gonna happen, is gonna be well outside the power envelope of what we're allowed to spend on a per server basis, right? So again, these are not bad devices. These Palo Alto people are great, they're great products, and they would argue that this is not the use case for the product, that it should be used in a corporate campus environment, and that's fine, it's totally fast enough for that. But you can't take all of these security services and centralize them into a single box and then make it cost effective to utilize at web scale. It's just impossible. What you have to do is you have to take each of these Palo Alto boxes, split them into software components, and then smear that software across hundreds of thousands of servers. And that's really the only way you can make it happen. Some other things people try to sell us. Security products that use a database as the back end, right? So there's a lot of SIM products. Anybody here work for a SIM vendor? Now you're not gonna raise your hand. Yeah, there's people, I've seen some t-shirts in here from SIM vendors. A lot of these guys say, okay, great, so you put our product and you could put a cheap database like MySQL or Postgres behind it, or you can do Oracle or DB2 or MS SQL, and then you just throw that onto like an EMC SAN, right? So that's great for most companies. It probably works for banks. Those guys have spectacular storage budgets. And the logs, the security sensitive logs from a bank would probably be measured in the tens to hundreds of terabytes probably per month, right? Just for scale, we have a product at Yahoo that has over 200 petabytes of storage for it. And when we talk about logs, we're talking about tens of petabytes of logs, right? And again, this could be a really good day for an EMC sales guy, but realistically, it's never gonna be cost effective for folks like us to run any kind of security scanning system on a system where you're dumping all of your data into one database that's on one like storage attached network or NAS device, and then you're making decisions from it. Practically too, there's no way that you can keep up performance-wise. What we need is anomaly detection systems that work on dumb, broad, clustered storage systems that run on super cheap hardware, right? And so for us, Yahoo invented this thing called Hadoop. So we use Hadoop everywhere. It's crazy, we have to use Hadoop for everything. No matter what you do, they want you to use Hadoop, and that's fine. But as a result, like from a security perspective, it is free for me to use things like Hadoop clusters, whereas it's extraordinarily expensive for me to go buy specialized hardware just for the security team. And this is where a lot of people are gonna have to go, right? We can no longer be building security products where all your data is in one place. We have to build security products where my data is spread over 1,000 or 10,000 machines. And those 10,000 machines can work in parallel to figure out if something funny is going on. Another thing people try to sell us, software that goes into the Windows kernel, which is already so spectacularly awesome, and then goes and screws with it and hooks into everything and inserts itself as driver filters and inserts itself into NDIS and hooks all these things in NTDLL to then tell me whether or not what is literally described by one vendor as a advanced APT. Yeah, some people got the joke. The A in APT stands for advanced, right? So. They'll tell you whether an advanced APT attacker has jumped onto that Windows box. A lot of companies are moving to a post-Windows enterprise environment, and I can understand how these products work for some folks, but for the most part, you're adding a level of instability that is not practical for most people to support. What we really need is a host-based intrusion detection system that works with modern systems like Docker on CoreOS, right? And there's some great opportunities here to think about how do I do things that are much less disruptive, and then also how do I deal with environments that have lots of Macs and lots of Linux. So here are some free business ideas. These are just go out, you can go start a company tomorrow if you want. Let me know if you have any questions about them. Things I would love to see. I would love to see a freemium key management system for production Linux boxes. I can go into Ubuntu right now and apt-get like 150 different X11 window managers, but I cannot pull down a single good key manager, right? This is a slight misallocation of resources by the open source community. And it's something that it needs to start with the security communities. We need to start to think about these things that people use in production environments that are absolutely critical to keeping us secure. And if we had, as an industry, the MySQL version of freemium key management, something that has multiple ways to authenticate, either through this thing is booting on a special Pixie network that is physically isolated. This thing is booting on AWS, and we're using out-of-band AWS communication to bootstrap it. But a key management system that, once you bootstrap it, creates a cryptographic identity on a per-node basis that then can be used to pull down arbitrary keys and certificates. You could build a huge number of things upon it, and as a business, it would be fantastic because most of your large enterprise customers would want official support, and they'd want all the closed source GUI stuff that you'd build to wrap around it. Once you had something like this, we could also have a open source good solution for overlaid networks, right? So instead of me providing layer 3 security services via very smart boxes, of which I have to buy hundreds, instead what I'd much rather have is a very small network kernel on my OpenStack host or my CoreOS host that now builds cryptographically secure overlay networks to different hosts of the same security level and provides layer 3 security that way, right? Security via crypto and software firewall on top of totally flat Ethernet networks, right? And again, there's a lot of opportunity here to build a commercial business around it. We're big proponents of bug bounty. We love the bug bounty system. We're customers of HackerOne, and they do a great job for us. But as we'll talk about a little bit later, when you're a company our size, you start to drown in these bugs, and it's very hard to tell the wheat from the chaff quickly. And so what we really need is the bug bounty world needs to have automatic verification, right? Instead of, we have this Egyptian kid, this 19-year-old Egyptian kid who doesn't speak very good English, but he reports really good bugs, so he videotapes them for us on YouTube, and then sends us a link, and then we can watch him recreate a bug. And that's fantastic, and that's great, but that's honestly a huge amount of work for him, and it's not scalable or automatically reproducible. What I'd much rather have is the ability for him to upload a Selenium script into our portal, that our portal then just turns green or red, saying, yes, your cross-site scripting bug was verified, or no, it wasn't. And if it turns green, we can auto-pay him. We'll pay him a little bit extra for doing the script, for doing the time to do the script, and then we can even look at that on an automated basis, make a judgment call from a computer of whether or not this is super risky or not, and then automatically file a bug with that test as a regression test against the engineers. And then my people don't even have to look at it. My people can just look at the queue of bugs being reported straight through from the outside community into engineering teams. So we're actually building this ourselves via Selenium, but we'd love to have people help. Because we want to open source this and see all the bug bounty companies do this. Don't try to patent it. This is now prior art. What we'd love to see is ARM CoreOS servers with remote attestation. So ARM is taking over the data center due to its power efficiency, especially in use cases like Hadoop and other big data systems, because you're not using a lot of CPU. Those systems are completely bound by network bandwidth and by the bandwidth of the hard drives, right, of the cheap consumer hard drives we use. And so as a result, ARM is getting big in those areas, but ARM lacks a lot of the VTX instructions and TXT and all those things that Intel has added that makes their chips not very power efficient. And so it'd be really interesting to see if we could have, using ARM Trust Zone or something, a cheap ARM server with lots and lots of hard drives that we could buy that does some kind of remote attestation and securely is able to put Pixie boot and securely get an operating system. OpenSSL with remoteable handshake. So as we've learned through the Snowden documents, there's this little database called Flying Pig shared between the 5 ICE countries, and that's a database of most of our private keys, right, of the people sitting in the room, private SSL keys. And this shouldn't be shocking, because our model for SSL termination is we're going to take this SSL private key and we're going to push it out to all of our front-end systems, which are the most exposed and easiest to attack systems in our entire network. What we need as an industry is we need OpenSSL or some equivalent with a remotable handshake, so that when an RSA or ECDSA handshake begins, that actual handshake is remoted to a centralized box that has HSM in it, and then after that, it's handed off to the edge server to do the perfect forward secrecy handshake, and then for all the encryption, right? And I've done some quick math, and you could probably have one core machine with an HSM support 20 or so front-end servers And that's something that would be a fantastic thing. You can either do a hardware HSM or a software security module. But this means building a good standard for doing this stuff between the front end for splitting up SSL, and so we'd love to see that. Okay, so I'm going to speed up a little bit so we can have some time for questions. Like I said before, we've had a little nihilism problem in the security industry. I want to talk about some of the excuses I've heard from different security folks and why I think we need to break through this if we're going to actually help normal people. So something that people say a lot when they see a startup or a nonprofit or an individual come out with a product that has some kind of security benefit is, this system is not secure against this super advanced attack or this super unlikely scenario, therefore you shouldn't even be trying, right? And we need to start to differentiate between the importance of pointing out the weaknesses of security systems in certain scenarios and then making a judgment call of whether or not that product should exist, right? Because it turns out we need to build systems that are useful for all levels of users and all kinds of adversaries, right? And right now we build security products for us. Who here uses GPG? Who uses GPG every day? Okay, yeah, you're lying, but nice. So that works for these kinds of folks up here, because these are the kinds of people that like to go to a GPG key signing party in Berlin after Christmas every year, right? And while that's great for people in our industry, it's not a scalable thing. And that's why we need to loosen up some of our restrictions as an industry of, if somebody screws up or somebody designs something that doesn't work in every single scenario, that we don't instantly say these people are horrible, this product is broken, therefore it shouldn't exist. This is also to all the reporters out there. When a person tells you this security bug means this product should not exist, you might want to think to yourself, maybe the people that designed this product had more knowledge of the actual threat vectors and had to make an intelligent balancing decision of whether or not they're going to handle a certain situation. Instead of just in big, huge type saying this thing's broken, these people should be tarred and feathered. Next thing we hear a lot is if you have a security system and you don't talk a lot about the details, that's security through obscurity, which, like most Bruce Schneier quotes, is misused all over the place. When people talk about security through obscurity being a bad thing, they're mostly talking about crypto systems, right? Where people say, I have this crypto system, I'm not going to release it, because those are the kinds of things that implementations are always going to get out and are going to be reverse engineerable. Same thing for like shipped software, right? This argument made a lot of sense when it was, Microsoft trying to do security through obscurity protections in a compiled DLL that then somebody could just dump into IDA and figure out how it works. The reality is, the vast majority of attacks these days are happening against systems through which there's no visibility for the attacker, right? That's one of the security benefits of the cloud, is that we're able to build security protections on the back end that the attacker doesn't know how it's working. And so building security systems that aren't perfect and that lose their usefulness if they're talked about publicly is not a bad thing if it increases the chances of attacking the vast majority of attackers and increasing the amount of effort that they have to expend, right? So we need to stop throwing around security through obscurity as an industry, as just a catchphrase to criticize people without thinking about whether or not that's true in this situation. The next one here is, okay, well, why are you going to do that? Because insert top tier intelligence agency here, they're just going to own up that person's system. They're going to put malware on that person's system and get the data anyway. And that turns out to be a factually true statement that is almost totally useless in any scenario in which it's used, right? The truth is when we build systems to protect normal users, we need to think about, one, what their actual threat scenario is. And the truth is the vast majority of people in the world, perhaps not in this room, but the vast majority of people in the world are not being individually targeted by a top tier intelligence agency, right? And it's totally true. Like, if the People's Liberation Army wants to read your email, you're going to have a very difficult month, right? Because they're going to put 12 people on it. And that's all they're going to be doing 24 hours a day. Well, not 24 hours a day. They work like 9 to 5 Beijing time, and all defenders know that, looking at their logs. So they'll work on that 8 hours a day. And that's all they're going to do until they get it, and that's a very difficult thing to protect against. But there is a value in forcing your adversaries, especially when we talk about governments, to expend resources and then to also raise the chance of detection, right? And so that's why when people talk about, oh, you shouldn't do, SMTP start TLS is useless because it's still unencrypted on the endpoint and somebody can get their machine owned up. That's totally true. But what you're doing is you're making it harder, right? You're making, if a government or an attacker wants to read somebody's email, they have to have an individualized attack, and they might have to spend something valuable like an O-day or spend a piece of malware that has yet to make it into virus total to get that. And they're not going to be able to do that for a billion people at once. which is the difference between trying to build security for a billion people and trying to build security for you and your friends. And then the thing I hate the most, I hear from the security industry all the time, is that we can't keep users safe because they're dumb. And so when I started my job, I gave my little St. Crispin's Day speech to all my employees. Yay, let's go get them. And I said, I have an open door. No idea is too stupid. But the thing I never want to hear from you is our users are dumb, right? If we're building systems that our normal median user, or even like our 25th percentile user, can't use safely, then we are failing. And we are failing in this room. We do not build systems that normal people can use, right? Who here has ever tried to teach their parents to do something securely online? Whether that's manage their passwords, send an encrypted email, right? And how hard is it? Was it easy, or did it take up all of your Christmas break? Right. That is wrong. They should be able to do that themselves without having a son or daughter who works in the security industry. And that is a failure that we really need to stop. And part of it is we keep on saying users are dumb, we can keep them safe. Yes, it's true that a normal user will type their password into anything, right? That just means we have to get rid of passwords. Yes, it's true that a normal user will trust a website that has this crazy URL that has like somehow every country code of every attacker country in it, amazingly. Like how did .ru, .romania actually work? And that they'll still type their password in that and they'll still download software. That just means that we need to make it easier for them to understand that that's a bad thing or to stop them from doing it. And something I'm starting to learn is we need to start to be a little more of security paternalists. We need to make security decisions on behalf of our users. If you want to give an out for advanced users, that's great, but make it clear to them that they're doing something dangerous. Okay, so what are we doing at Yahoo? Talking about like our problems at scale and the problems of kind of making security products for normal people. What are we doing? So here's just a quick org chart in case any of you end up being a CISO one day you might find useful. What we've done is flattened our security org a lot, created a bunch of different divisions. So we have a corporate team that just does network and corporate security. We have an operations and monitoring team that runs our equipment, runs our Splunk and Hadoop stuff, and that does all of our scanning. We have a product security engineering team. They embed engineers into different products to help them write their products more securely. They also build our SDLC tools to do code scanning. We're building a Paranoid Labs, which is a standalone R&D division to do brand new research and development. We have a penetration testing team with a brand new leader who I'm going to just announce in a second. We have intelligence investigations and response team that obviously goes out, figure out who the bad guys are, and then does all our investigations. We also, our e-crime team rolls up into them. We have a risk and vuln management people. They're the ones that make sure I never have to talk to an auditor from KPMG. And then we have a brand new privacy engineering team that is going to be focused on building privacy-enhancing cryptographic technologies for end users. So some people who I just like to say hi to just because they're in the room, brand new people. So we announced a couple weeks ago that we acquired the team from Leaf Security Research in New York. Chris, you want to stand up and say hi? Is Doug in the room? Okay, good. I don't have to fire you. There's Doug and there's Chris. Oh, good. He's got the shirt too. Oh, man. So Chris is going to run our penetration testing team out of New York. Both of them are famous, really good penetration testers, and they're not only going to be breaking into our stuff, but they're also going to be breaking into open source and other commercial products, and then releasing those bugs publicly, responsibly, of course. And then I'm happy to announce today that we've just hired Yan Zhu from EFF, who's famous for doing work on Secure Drop. Yan, you want to stand up and wave? She's also wearing a shirt. That shirt originally had sleeves. That is not a regulation Yahoo Paranoid shirt. So Yan is the first engineer on our privacy engineering team. She'll continue to be able to work on Secure Drop, but she's also going to work on some end user crypto stuff that I'm about to talk about. We do a lot of transport encryption stuff. My message here is like, it's easy to do the basic stuff. As an industry, we need to make it easier for normal companies that don't have huge security teams to do other things like ECDSA certificates, HSTS all the time, and then moving to new Cypher suites. We're making a lot of changes. We use this thing called Apache Traffic Server, which is a very popular Apache caching server, and so we're making a lot of changes and we're pushing those out to public code to be able to support these kinds of things. We're also pushing very hard on our cert vendor to do certificate transparency, and I just found a couple weeks ago that they have agreed to do cert transparency for all of our, these are people who have been blocking cert transparency for a very long time, and they've given up. Which is great, because I've never had the power over 7-figure contracts before, and it turns out to be really useful, again, people to support security features. We announced in March that we've we completed a backbone encryption project. I just wanted to bring up, this is one of the things when you're outside and you're like, oh man, you're just gonna encrypt your backbones, just buy an IPsec box, right? Whatever, dude, or just do some Stunnel on a Linux box. So this is a very simplified map of our backbone. This is only the top tier backbone, so this is the backbone between our Yahoo-owned data centers. This doesn't include like the 80 other locations that we have in non-Yahoo data centers that we often have leased lines into. Each of these lines is at least a 10 gigabit per second connection all the way up to like 200 gigabits per second. So it turns out when you're working with a network of this complexity, you can't just go buy an IPsec box. In fact, there's only 3 companies that make hardware that operates at the speed, and then that claim to, and then when we tested them, it turns out only 1 company actually makes hardware that operates at the speed. And even then, it breaks all the time, right? And so what we as an industry need to get, and one of the things I talked about, freemium key management and TLS overlay networks, is the future for people doing backbone encryption at scale is going to have to be point-to-point encryption between servers themselves, right? That you're gonna have to do TLS between these servers, and we're already doing that, and we have a special policy-based routing that all of our TLS encrypted stuff gets to go over the backbone directly, and then the other stuff runs through the IPsec box. And we want to move to 100% that way, and it would be great if most people in the industry did it, because then we don't end up with these situations where you buy these real expensive boxes that then break, and then while they're broken, you end up with data synchronization issues measuring in the petabytes between data centers. We're doing a lot of self-service security stuff. So when you have 80 plus products that are officially supported in like 60 countries, it turns out that you can't build a security team that can look at all those fast enough. From a speed perspective, especially in the mobile world, our mobile teams often do weekly pushes out to the App Store, right? And so what we have to do is build mechanisms to allow people to self-service in security, and it'd be great to see some of these mechanisms be open source. I don't know why I can't get an open source Objective-C library for iOS that allows me to do authentication smartly, that correctly uses the DP API, that does TLS pinning, right? Every company's re-implementing this themselves, usually incorrectly, and this is the kind of thing we should be doing as an industry. We operate a huge bug bounty, probably one of the largest bug bounties on the internet. This is our graph of what this year's looked like. We've spent about $670,000 so far this year. Bug bounty is great, but it does need to improve in a couple of ways. One, like I said, we need to have automatic verification, so it's very easy to know which bugs are real and which aren't. We also, as an industry, need to start to kind of lighten up a little bit on people that operate bug bounties and understand the constraints they operate under if we want bug bounties to succeed. Like, I think the internet companies will be running bug bounties forever, but what we really should move towards is that the people you get your car insurance from have a bug bounty, right? And the retailer that you go and you buy stuff from, that they have a bug bounty. And right now they don't. And one of the reasons they don't is they see how people treat us, right? So we've had a couple of situations where we'll have days where we'll get 120, 130 reports, and 80% of them are incorrect, out of bounds, or completely unreadable. And by unreadable, we'll go get translators to read if you don't speak English. I just mean completely, like, you can't understand what the person's trying to communicate to you. And so when our people look at those and try to investigate them, sometimes they're gonna make mistakes. And we've had a couple of incidents where our people put in the bug bounty, like, I don't understand, I don't think this is a bug. That reporter takes a screenshot, sends it to, they send it to a news reporter, and then that incredibly lazy news reporter writes a story saying Yahoo doesn't care about this kind of bug. And that's not true. The guy whose job it is to read this junk all day, these horrible, horrible bugs, made a mistake or couldn't understand it once. That doesn't mean as an organization we don't care about the bug. And I'm happy to take that because I'm happy to go argue that we did the right job and to clean it up, and it's not a big deal. But as long as the bug bounty industry works in this way, that if you make a mistake or you don't fix a bug for 30 days, that they're gonna run straight to a reporter and they're gonna make a big deal and say that you suck, then people aren't gonna do bug bounties, because then it feels like you're paying people to blackmail you, right? And that doesn't sound like fun. That doesn't sound like all of us working together, right? So just something as an industry that we need to think a little bit about getting a little more realistic about how bug bounties work. We did this thing called bug bankruptcy, which has worked out really well, that I recommend you doing if you're at a big company. So when I started, we had over 2,000 security bugs. Some of them are very old or for products that no longer existed, and everybody's got this problem that bugs get misfiled, they get filed against the wrong people, they're miscategorized. And looking at it, I thought, okay, we could spend a year trying to recategorize these, but during that time, nothing's gonna get fixed. Or what we can do is we can close all the bugs and then reopen only the ones we care about. And so that's what we did. We closed all of our security bugs, and we only reopened the ones that we were able to verify are still relevant, and then we made sure that we filed them to the right people. And some of the things that have been really effective that we've done detailed descriptions and mitigation instructions, right? These don't have to be necessarily super personalized, but if you're saying, fix this MySQL issue and you've seen it 5 times, then you should have a pretty good description you can copy and paste in. Accurate prioritization. So if you're going to have a priority 0 through 3, then not everything's priority 0. You need to save that for the real stuff. Otherwise, people are going to start to ignore you. Consistent follow-up and real-time reporting. So something that's worked really well for us is that the leaders of all of our business units have a real-time dashboard to see how many bugs are hanging over them. And our CEO every week confronts them with that number, which turns out to be extremely effective at getting them to care about bugs. Executive visibility up to the highest level. And then something that's worked especially well for me is I've convinced the company that I'm a total madman and set like really hard deadlines for certain type of super critical bugs, and then told them if this bug doesn't get fixed, I'm going to pull this machine off the network, right? Because if your machine's not important enough to get patched, it's not important enough to be running on the internet. And this has actually worked really well. We had a situation where the first time this happened, 2 weeks to go to the first deadline, we had over 20,000 machines that were missing patches that qualified for this. And people are like, oh, Alex isn't going to turn off 20,000 machines. And I'm like, oh, look, I'm working on my resume. It's getting touched up, and I'm planning a vacation, right, for after I get fired. But yeah, the last things I'm going to do is I'm going to be a crazy man. I'm going to pull the plug. And it's less about them actually believing you're going to do it. It's more about demonstrating that you have skin in the game too. That, right, as a security professional, you're willing to put your own reputation on the line, saying these bugs are real. They're so real that I'm willing to tell the CEO that I'm about to pull these machines off and take entire sites off the web. And so it's a really good, effective way of demonstrating that you care as a security person, and that your bugs are real and that you stand behind them. Just make sure that you do the prioritization correctly and that they're real bugs, right? And so another thing we're happy to announce today, the thing that Jan's going to be working on in the privacy engineering team, is in 2015, next year, we will be releasing end-to-end encryption for all Yahoo Mail users. Oh, thanks. So this turns out to not be really easy to do at the scale at which we operate and at the diversity of people. So what we've done right now is that we're working with Google on this. We've taken their end-to-end plugin and we've cut out the crypto core stuff, and we're working with them to make sure that stuff's abstracted out so it stays nice and the same no matter who's implementing it. And we've built some of our own front-end code to integrate with our web interface. And we've built an API into our Yahoo Mail server, right? So this is running on a couple of days ago on one of our internal systems that have the proper JavaScript in the mail front end. And we've modified it to have a little more integration, and we're starting to do experiments with how do we properly integrate with the normal webmail user experience. So as you see here, you have already seen us do a demo of somebody doing something that's not really that safe in our threat model, which is they started composing a message in the normal webmail window that they've been trained to use for a decade, which in theory is in control of the DOM that we control, and then it moved out of the DOM into the plugin. And so this is what we're experimenting. We're trying to figure out how do we train users to understand this part of the message is secure and this part's not. That metadata, if we're going to use SMTP, metadata is never going to be secure other than in transport, thanks to Start TLS. Subject lines are going to probably stay insecure because it's going to be the only thing that you can search upon in a search index going forward. And so we're going to be experimenting in a lot of different ways and building a key management infrastructure that allows you for automatic detection of Yahoo Mail users, and our goal is to have complete compatibility to Gmail. And we're working with the Google team so that when both Gmail and Yahoo release our final products, that you're on Yahoo Mail and you can type, if I'm a democracy activist in Sudan and I want to talk to Amnesty International and they have a Gmail account, then I can type amnesty@gmail.com. It will automatically figure out that Gmail user has a public key that has been certified from Google to be correct. And it will say, do you want to encrypt? You say yes, and that's all the key management you have to do. Clearly doing that in a way that is now also invulnerable to interference is something that is interesting but also cryptographically doable. So that's what we're working on, and then what we're also trying to work on is the next stage of authentication, which it's pretty easy for us as the people who own the domain and own the mail server to say, yes, this is really this guy's key tied to this yahoo.com email address. But the problem is that we're going to start to imply for users that means we verify that person really is who they are, right? So anybody in this room can go register Alexander C. Stamos at yahoo.com. In fact, somebody's probably doing that right now since I said it. and then pretend to be me. And so we could build a key management system that makes it really easy to say, yep, this is really the key for Alexander C. Stamos at yahoo.com. But the fear is that once we start to move this out to normal people, it's going to be very difficult for them to understand that that doesn't mean that Yahoo's actually looked at that person's driver's license and verified that their name really is what it is. And so as an industry, we need to start to think a little bit more about how do we tie meat space identities to cryptographic keys in a way that is both transparent but not spam-tastic. And that's the other problem that you have operating at our scale is anything we do, spammers are going to try to find a way to monetize it, right? And so it's not as easy as just opening up a GPG server and then just throwing all your keys in, because the spam people love that kind of stuff. In fact, they do this right now. Go create an email account and put it in the MIT PGP server and count how long it is until you get your first spam message, right? And so there's a lot of interesting things to be worked out here, and that's why it's going to take a while. We won't be launching this until next year, but we are going to have it open source. We haven't released it quite yet because we're not ready to push this code to production Yahoo Mail, and I didn't want to release a plugin that doesn't work on the real site. And so this fall, we'll be pushing it to production mail. We'll be releasing the plugin open source. And then we're hoping to design and implement the key server infrastructure and all that kind of stuff in an open, transparent manner that then people can go verify. And if you are super, super paranoid, you can go do your own plugin build and load it into your browser yourself, and then feel confident that we haven't backdoored it or anything like that. So anyway, so we're working on end-to-end encryption. Jan's going to work on that, and we're looking for more engineers. If you want to come build crypto products for 1 billion people, come see me afterwards. So in conclusion, and I think we're going to have a couple minutes for questions, so that's great. A lot of people are really glum these days in the security industry. I see a lot of really dour people on Twitter and on Hacker News and in person where people are always talking about how bad things are. And we really can't think that way. Our profession has never been this important, right? We are in a world historical moment right now when people in our profession have the ability to change whether or not the internet is going to be the center of freedom and free expression and of democratization that we always thought it should be, or if it's going to be a tool of oppression and censorship and monitoring by both democratic and non-democratic governments, right? That's something that's going to be determined. That die is going to get set in the next 5 years. 5 years from now, it's going to be done, right? Because we're going to be past all of the disclosures, the sense of urgency is going to be gone, and the kind of the technical underpinnings are once again going to be set in stone for another decade. And so while that sounds horrible, it's fantastic because it means you as a person have the ability to actually make a change that you're going to be proud of one day. And that should make us happy. Even if it's a hard job, I'd much rather have the opportunity to make difference than to be in a situation where things are horrible and I have no ability to change things. The result is, though, everybody in this room is now a moral actor. None of us are neutral anymore, right? Every time you go and you decide to make a feature exist or not, or you make a security trade-off, you're either enabling or disabling something good or bad that's happening to somebody on the internet, and no longer can we pretend that we don't know. Ignorance is no longer an excuse in our industry. And so just take a moment to think about that when you go about your day, and think about, am I acting in a way that is either morally good or bad per whatever ethical guidelines I have. Now, I've spoken out against people that sell exploits and stuff, and even if you believe that's good, you need to start to think of, I'm not just selling something that its use by somebody else is neutral. You need to think to yourself, is doing this actually making the world a better place? And if you believe that that's true, then good for you, but don't pretend that you don't actually have a role to play on this planet with all of these people who are looking up to us to do things right for them. And so, when you think about that, remember that trust is more than security. Security is again, the technical ability to live up to your promises. Trust is making the right promises. So let's make the right promises to people, and then let's work really hard to live up to them whenever we can. And because this is a world historical moment, this is the chance that we have that perhaps like our grandparents had during World War II, that people had during the Civil Rights era, to take a stand. Think a little bit while you're here in Vegas. Maybe you can go out in the desert and go meet your spirit animal, Jim Morrison style, or you can reflect while you're at the poker table. But take a little moment to think a little bit about whether or not what you're doing right now is the kind of thing you're going to be proud to tell people you were doing 30 years from now. Whether you have grandkids or friends or young people, or you're going and you're addressing a big crowd of young people, that you can say in 2014, I was on the right side. And that's kind of my biggest message is, let's not be glum. Let's be happy about this opportunity, and let's just be thoughtful about what we're doing with it. So thank you very much for coming. Here's my email if you have any questions, or send a resume. Thank you. So I think we have 5-6 minutes. There's mics up here. Yes, sir, if you might want to grab a mic or. Yeah, there's mics right here. Any other mics? Anybody see them? Well, here's one if anybody has any questions. Yes, sir.
So if Yahoo is encrypting emails, how is it going to make money off mining the content to pay for the service itself?
Right. So since there's a reporter from the Wall Street Journal in here, I will say we predict absolutely no revenue impact from encrypting emails. The truth is that the kind of targeting that happens in email servers does not usually happen against person-to-person emails, right? Like when you communicate with your friend or your mother, you're not having communication that's syntactically useful for an ad targeting perspective. And the kind of commercial email that is, like you getting a ticket from United saying, have a fun time, you're flying to Las Vegas, and then you see an ad saying, go stay at this hotel. That stuff, honestly, is never going to be encrypted end to end. So I don't think there's going to be any problem for the webmail companies to still make money.
Hello.
Hi.
Given the recent vulnerabilities, deep vulnerabilities such as Heartbleed, what is your perspective on our fundamental reliance on OpenSSL?
That's an excellent question. So I feel two ways. I mean, I'm glad Heartbleed happened in a way because it did help us kind of reassess and look back at all of the things that we've built our systems upon. The flip side is we need to not focus too much on one single bug. The Heartbleed bug, that everybody in this room knows that we get 2 or 3 of those bugs a year. They just generally don't have logos and incredibly overactive press departments trying to make a big deal of them, right? So I don't want to focus too much specifically on OpenSSL. I do think it's important as an industry for us to think about what the fundamental technologies are that we rely upon, especially if those things happen to be things written in C that do ASN1 decoding and have incredibly complicated state machines that even the inventors of the spec don't understand. And so honestly, my personal opinion here is it's 2014. It is insane that we are writing system code in non-memory safe languages still. Like, Kernighan and Ritchie had a buffer overflow in their book, right? So if Kernighan and Ritchie aren't smart enough to write C code, then you are not smart enough to write C code. Like, that's basically my fundamental thought. And so I think we need to move beyond not just like refactoring and stuff, but I would love to be able to have a good industry SSL stack that's made in a type-safe language, or that like you're doing C++ compilation into LLVM bytecode, and then you're doing memory management stuff, and we'll take the 5% performance hit or 10% performance hit if that means that we have memory and type-safe code. Obviously, not all security bugs are memory overflows, but it is kind of crazy to me that arbitrary memory access still exists in 2014 on server production hardware.
So just as a quick follow-up then,
Yeah.
Is Yahoo investing in building such a system or potentially funding such a system? Like there's been talk of public companies coming together to publicly fund things, advances to OpenSSL?
So there's like, everybody's working on OpenSSL, so I don't want to chase where the ball was. I'm trying to chase where the ball is going, right? So we're building this pen test team, and we're going to be doing a lot of investment in fixing stuff, but we're going to start on the things that have gotten very little review. Like, everybody's looking at OpenSSL. The marginal benefit I can add by writing a $100,000 check or by putting a couple of my people on it is much smaller than if we go and we look at the things that people haven't looked at. And so that's why we're looking at Hadoop. That's why we're looking at ATS. That's why we're looking at things like Chef. That's why we're looking at systems that are also super critical and don't happen to have 20 companies trying to throw their logo on we're doing a pen test. I mean, I don't want to do security by PR, right? And so I think it's great that people are working on OpenSSL. We're kind of keeping our options open. We're going to watch to see Libra or boring SSL or whatever the winner is. Once it seems like we know what direction that's going, I'm happy to participate. But right now, I would rather have my people look at the stuff that hasn't been looked at professionally.
How effective do you feel privacy is as a selling point to the general public?
That's a great question. How effective do I think privacy is as a selling point? Much more effective than it used to be, right? I think one of the problems is we as an industry have done a really bad job of describing what privacy is in a way normal people can understand. And it's because of that really bad job that we end up with politicians making really lazy analogies like the NSA is not bad, Facebook's worse, right? And if people had a real good understanding of what privacy means kind of in the context of your relationship with the government and the context of bad things happening to you, the fact that Mark Zuckerberg can send you nice ads is very different than organizations that have drones and SWAT teams, right? And so I think our industry needs to start to maybe even move off of the word privacy, because it's it's not like it's a bad word, but it's just been overused in too many situations to include nation state spying, to include malware, to include account takeover, to include ad targeting, to include all that kind of stuff, and start to talk about the situations in which our personal data is used and have a real focus on the bad outcomes, less about kind of where that data is, because the truth is, our data is going to be out there. It's going to be hard for us as individuals to know exactly where it is. We need to focus on making sure the outcomes for us are not bad. That didn't really answer your question. It's not as good of a selling point, but I think it's going to be better. Okay, I probably can take one more question.
Yes. I understood that you have a custom log management tool with Hadoop as a backend.
I'm sorry, I couldn't understand.
That you have a custom log management tool with Hadoop as a backend.
Yeah, do we have a custom log management tool?
I understood that, but I was wondering, how do you audit your databases? If you use proprietary software or a vendor, or you have a custom way of auditing the SQL databases or NoSQL?
Yeah, I mean, so we have a lot of different databases. We have different ways for each. I'd rather not get into too much detail. Okay. But yeah, I mean, a lot of our focus is on Hadoop auditing, and then something we've done a lot of work on internally and contributed out open source. Because it's a lot harder and a lot more important for us than things like MySQL accesses. Okay, so I'll still be around. We have a break if you guys want to ask questions, but thank you very much for coming.